The topic of my presentation is confocal conics. So those conics which have same focal points or foci are called as confocal conics. Let us see. For example, these are the foci. With this foci, we may draw two ellipses. So now these two ellipses, they both have the same foci. Thus they become confocal conics. Similarly, you may draw parabolas with the same foci. Let the equation of confocals to an ellipse be x square upon a square plus y square upon b square is equals to 1. Now we know that if a is greater than b, then the coordinates of foci would be plus minus ae comma 0, which will be is equals to plus minus a square minus b square comma 0. Now let the equation of confocal be x square upon a square plus lambda and y square upon b square plus lambda is equals to 1. It means that we may change the value of lambda and thus we may obtain confocal conics of different points. The coordinate of foci is plus minus under root a square plus lambda minus b square minus lambda comma 0. Which is ultimately is equals to plus minus under root a square minus b square comma 0. Thus 1 and 2 have same coordinates of foci and they are known as confocal conics. Now I would be telling you some properties of confocal conics. The first property is confocals cut at right angles. Let two equations of confocals be x square upon a square plus lambda 1 and y square upon b square plus lambda 1 is equals to 1. The other equation of confocal would be x square upon a square plus lambda 2 plus y square upon b square plus lambda 2 is equals to 1. Now let us suppose that equation 1 and 2 cut at some point. Let that point be alpha comma beta. Now alpha comma beta would satisfy x and y in this equation. So we would satisfy the same here. Alpha square upon a square plus lambda 1 plus beta square upon b square plus lambda 1. This will be equation 3. Another equation would become alpha square upon a square plus lambda 2 plus beta square upon b square plus lambda 2 is equals to 1 would be equation number 4. We would subtract this equation. Subtracting equation 3rd and 4th, we would obtain alpha square upon a square plus lambda 1. We would subtract this entire thing. Now here we have subtracted it. 1 minus 1 would become 0. From here alpha square would become common. We would take an LCM here. Alpha square would be common. Then we would subtract it. Similarly beta square would be common here. And then we would take the LCM of b square plus lambda 1 and b square plus lambda 2. Now you may see alpha square is common. Here we have obtained lambda 2 minus lambda 1 upon a square plus lambda 1 and a square plus lambda 2 plus beta square lambda 2 minus lambda 1 b square plus lambda 1 b square plus lambda. Since lambda 2 minus lambda 1 is common, we would take it out and the equation would become somewhat like this. Now let us suppose the tangent at alpha comma beta to equation 1 is given by alpha x upon a square plus lambda 1 plus beta y upon b square plus lambda 1 is equals to 1. Then for the second equation it would be alpha x upon a square plus lambda 2 plus beta y upon b square plus lambda 2 is equals to 1. Now from this equation we would have the value of y which would be our m1. It would be this. We would subtract it 1 minus alpha x upon a square plus lambda 1. It would be a square plus lambda 1. So when it would come to this side, the value of y would be this, which means we have got our m1, which would be minus 2 upon b square plus lambda 1 upon beta a square plus lambda 1. Now similarly from equation 7 we would have our m2. M2 would be minus 2 b square plus lambda 2 and beta a square plus lambda 2. Now we know that to prove that two lines intersect at right angles. Similarly here we have to prove two confocals intersect at right angles. We will have to prove m1 m2 is equals to minus 1. Now the value of m1 is written here, value of m2 is written here. When you would substitute the values of these ones from equation number 5, This is your equation number 5. See, you have the value of b square plus lambda 1, b square plus lambda 2. So the same values which are required here. So when you would make use of this equation, we would get the answer -1. So this is what we had to prove, since we know that when m1 m2 is equals to -1, conics cut at right angles. So this was your very first property. The second property is, through a given point in the plane of a conic, two confocals can be drawn. One of them is an ellipse, other is a hyperbola. So now we have to prove this property number 2. Let the equation of the conic be x square upon a square plus lambda plus y square upon b square plus lambda is equals to 1. Suppose that alpha beta is a point in the plane of equation 1. Satisfy the same here. When you would cross multiply and take the LCM, you would get somewhat like this. And when this moves to this side, we would get equation number 3, which is a quadratic equation of the two confocals present. We would suppose beta square plus lambda is equals to mu and lambda is equals to mu minus b square. Putting in equation number 2, it would become alpha square upon mu a square minus b square plus beta square upon mu is equals to 1. Now we know that E, the eccentricity, is given by under root a square minus b square upon a. So when a would move to this side and we would square it on both the sides, we would get e square upon a square is equals to a square minus b square. Substitute the value of e here. Further solving, you would get an equation somewhat like this: mu plus a square e square minus alpha square minus beta square mu minus alpha square beta square e square is equals to 0. When you would look at this equation very closely, you will find that equation 4 is a quadratic equation. Mu1 mu2 is equals to minus alpha square beta square e square is equals to this. Now mu1 mu2 is negative, b square plus lambda is equals to mu1, which is positive. Mu2 is negative, mu1 is positive, one root is negative, another is positive. This means that it is a hyperbola. Now we have to consider the second situation of it. This. Let us take another equation, and here we would suppose a square plus lambda is equals to mu. Substitute the value of lambda. Further solving it, you would get this equation the same way as we proceeded in the previous one. A square e square is equals to a square minus b square. Substitute the value in this equation. Here again you would get a quadratic equation somewhat like this. Now equation 6 is a quadratic in mu. Here are two roots of equation 6. Mu1 mu2 is equals to alpha square a square e square. Here you may see that mu1 mu2 is positive and mu is equals to alpha square plus lambda, that is also positive. So this proves that this would be an ellipse. When both the roots are positive, it becomes an hyperbola. So that was a property which we had to prove. So these are the two properties which we have proved of confocal conics. I hope it helped you all. Thank you.